Imagine for a moment a glowing object hurtling into our solar system at the speed of a cosmic bullet. Imagine that everything you believe you know about comets, asteroids, and interplanetary visitors is called into question. This occurs when the object exhibits behaviors that no textbook anticipated. From the moment I began studying theoretical physics, I knew the universe was full of oddities. Yet I also discovered that science advances when we confront the unknown with humility and wonder. When the discovery of a new interstellar visitor named 3I Atlas was announced, I realized we were facing something extraordinary. Not only because it was the third object we had detected from another star system, but because its trajectory, composition, and the reaction it provoked in our planet's most prominent space agency deviated from everything we had seen before. This narrative is the story of how a mysterious comet not only challenged our scientific expectations, but also elicited a response from the National Aeronautics and Space Administration so unusual that many wondered if secrets were being concealed. From the first time I heard about 3I Atlas, I closely followed every update, every blurred image, and every spectral analysis. What I am about to relate is not the product of conspiracy or speculative fantasies. It is an account of a real phenomenon through the eyes of someone who loves science and recognizes when reality seems like fiction. As a child, I remember gazing at the stars, imagining that one day we might receive signals from distant worlds. Now, as an adult, I find myself before an interstellar visitor that raises uncomfortable questions. What is it really? Where did it come from? Why does it elicit such varied reactions among scientists, government agencies, and enthusiasts? And most importantly, what can it teach us about the universe and about ourselves? Throughout this narrative, I will explore these questions with rigor, emotion, and a profound desire to understand the truth hidden behind sensational headlines. In my career as a physicist, I have analyzed models of comet formation. I have participated in conferences on interstellar visitors. And I have debated with colleagues about the possibility of life in other worlds. But I had never seen the scientific community so divided. Some cling to traditional explanations and remind us that nature is wondrous. Others explore bold hypotheses about alien probes or unknown technologies. Meanwhile, telescopes aim at the sky and record data that sometimes contradict our own predictions. Social media buzz with conspiracy theories. And the media alternate between information and alarmism. Amid all this noise, my goal here is to separate what we know from what we imagine. And to do so with the respect that such a rare phenomenon deserves. The narrative begins on the 1st of July, 2025. On that day, the asteroid early warning system known as the Last Alert System for Earth asteroids, operating in northern Chile, detected a point of light moving at an unusual speed across the sky. Astronomers monitoring the system noticed that its orbit did not match the elliptical trajectories followed by ordinary comets orbiting the Sun. By calculating its orbital parameters, they concluded that it followed a hyperbolic orbit. This means it was not gravitationally bound to our system, but had come from outside. It was then classified as the third interstellar object discovered by humanity, after Oumuamua in 2017 and Borisov in 2019. Unlike those two, 3I Atlas was detected with far greater lead time before perihelion. This gave scientists an unprecedented opportunity to study it. From the moment it awakened from hibernation on the outskirts of the solar system to its closest approach to the Sun, initial estimates, based on its brightness and activity, indicated that its nucleus might measure several kilometers in diameter, perhaps up to 5. Its speed exceeded 130,000 kilometers per hour, making it the fastest-moving object observed in the solar system at that time. Throughout my career, I have seen numerous light curves and orbital tables, but none with such a pronounced graph as this one. The fact that it was moving at such speed was in itself a clue. An object traveling at that velocity and departing along an open trajectory must have wandered through interstellar space for billions of years. Every passing second slightly reduced the distance to Earth. But it would never approach close enough to threaten us. Its calculations showed that at the closest point to our planet, it would pass more than 260 million kilometers away. This enormous distance reassured most of the public. However, those of us who understand the dynamics of small bodies knew the story did not end there. Together with colleagues, we calculated that perihelion would occur at the end of October, 2025. At that point, it would be approximately 130 million miles from the Sun, barely inside Mars' orbit. This forecast gave us months to prepare telescopes, instruments, and observation plans, as well as to organize space missions that could intercept its tail or analyze its chemical composition in detail. What we did not know was that, during this time, the comet would exhibit behaviors that did not fit our models, and that the agency bearing the greatest responsibility for protecting Earth from impacts, the National Aeronautics and Space Administration, would react in a manner that many found alarming. The first official communications were restrained. The National Aeronautics and Space Administration issued a brief statement to confirm that the object followed a hyperbolic orbit, and that it posed no danger, as it would never approach closer than 1.6 astronomical units to Earth. The message emphasized that this was an exciting scientific opportunity, and that the international community, through the Minor Planet Center and the International Asteroid Warning Network, would monitor its evolution. What was not stated publicly at that time was that, internally, an alarm had been triggered. I learned from involved colleagues that the agency had discreetly activated planetary defense protocols, typically reserved for cases of potential impact. The International Asteroid Warning Network, sponsored by the National Aeronautics and Space Administration, launched an intensive observation plan, including coordination of telescopes in the United States, Europe, Chile, Canada, and New Zealand. There was even talk of preparing a rapid probe that could fly by the comet to study its composition. The reasons for this mobilization were not collision risk, but the emergence of data suggesting the object was changing speed and showing signs of unusual activity. One of my colleagues with access to the agency's internal meetings confided that the National Aeronautics and Space Administration preferred silence until there was greater certainty about what was happening, to avoid premature speculation. However, the absence of official information bred rumors. Some media began insinuating that the National Aeronautics and Space Administration was hiding something, that its scientists had detected radio signals or that the comet had emitted strange light flashes. Most of these stories were not based on facts, but in a climate of uncertainty, they were like gasoline on a fire. The true explanation was more prosaic. The National Aeronautics and Space Administration is governed by procedures requiring analysis before announcements. No one in the agency wanted to repeat the media chaos surrounding Oumuamua, when lack of data led to heated debates about whether it was an alien spacecraft. This time, the agency chose a cautious stance, relying on the international network and the Minor Planet Center to centralize information. Nevertheless, the coincidence of this silence with the activation of defense protocols and the start of a United States government administrative shutdown fueled suspicions. For many, the National Aeronautics and Space Administration began moving as if facing a threat, although public messages insisted there was none. The particular characteristics of 3I Atlas began to reveal themselves shortly after discovery. One of the first to draw attention was that instead of a classic dust tail pointing away from the Sun, the initial images captured by the Hubble Space Telescope and the Gemini Telescope in Chile showed a beam of material seemingly erupting toward the star. This was dubbed an anti-tail or reverse tail. For ordinary comets, the tail always points away from the Sun because solar wind pushes gases and dust outward. In this case, the photos seemed to contradict this rule. At first, many thought it was a perspective effect. If previously ejected dust grains moved in a way that crossed our plane of view, it could create the impression that the tail pointed toward the Sun. But when temporal sequences were carefully examined, it became clear that a jet of carbon dioxide and other molecules was indeed emerging directly from a hemisphere facing the star. This discovery coincided with another surprising fact. The comet began activating much earlier than expected. While still more than 3 astronomical units from the Sun normally, solar system comets remain inactive until solar heat begins sublimating water ice and other volatiles. 3I Atlas, however, seemed to awaken while still in extremely cold regions. The most reasonable explanation was that it contained compounds sublimating at very low temperatures, such as carbon monoxide and carbon dioxide. This was confirmed when the James Webb Telescope detected a proportion of carbon dioxide in its coma nearly 8 times greater than water. In local comets, water dominates the coma's composition. Here, carbon dioxide was the protagonist. But the most discussed anomaly occurred when the Very Large Telescope in Chile detected nickel vapors in its gaseous envelope, at a distance where normal comets should not expel metals. The strangest part was that observations showed nickel tetracarbonyl, a compound humans use in industrial processes for metal refining. To top it off, iron was not detected in equivalent proportions. This challenges our understanding of cometary chemistry. These findings troubled me because they suggested a different origin or process. A nucleus capable of expelling nickel and nickel tetracarbonyl without iron-implied temperatures or reactions we do not associate with natural comets. Meanwhile, the National Aeronautics and Space Administration observed in silence. Its telescopes collected data, and its laboratories analyzed spectroscopy. But they shared little with the public. The combination of early activity, a sun-oriented jet, and the presence of industrial compounds ignited debate about whether we were witnessing an extraordinary natural phenomenon or something beyond our models. Each time I reviewed the spectra and saw the nickel signal, I was overcome with a mix of fascination and suspicion. Another aspect that puzzled the scientific community was the orbital coincidence. 3I Atlas was not approaching our system at a random angle. It was doing so almost exactly in the plane of the ecliptic, the same band in which all planets move. Most interstellar visitors we had observed previously enter from above or below, crossing the ecliptic disk at steep angles. That a random object approaches within 5 degrees of this plane is, according to statistical calculations, unlikely. But the coincidences do not end there. Tracking its trajectory, we noticed it aligned to pass relatively close to Venus, then approach Mars, and later graze Jupiter before exiting the system. It was as if we had drawn a flyby route designed to study several planets in sequence, using their gravitational fields for turning or braking. This route was not only unusual. It also inspired comparisons with trajectories we designed for interplanetary probes like Voyager or Galileo. For some, it seemed coincidental. Others, like astrophysicist Avi Loeb, considered it a sign of intent. In July, Loeb published a paper pointing out that the combination of the anti-tail, ecliptic alignment, and presence of metallic compounds could be interpreted as a form of controlled propulsion. He suggested that 3I Atlas might brake using sun-oriented jets to regulate speed, and that the trajectory leading it near several planets might be part of a study plan. In the same vein, its mass was calculated to be extraordinary. Based on the observed small non-gravitational acceleration, some scientists estimated it could weigh tens of billions of tons, thousands of times more than other known interstellar objects. Such a large mass would be necessary for gas jets not to deflect its orbit. But then another question arose. How does such a massive object form in interstellar space, where material density is extremely low? The natural answer is that it was born inside a star system and then ejected. But the existence of a body this size traveling billions of years and arriving precisely in our ecliptic seemed to defy probabilities. The International Asteroid Warning Network, acknowledging the uniqueness of this trajectory, announced a global observation campaign lasting 2 months. From late November to late January, dozens of observatories, agencies, and amateur astronomers would participate to refine tracking methods and collect as much data as possible. This international mobilization, accompanied by the National Aeronautics and Space Administration's caution, showed that something about this comet was out of the ordinary. As the list of anomalies accumulated, the idea that it was simply a natural comet began to waver in many minds. It was then that some scientists and popularizers dared to advance a bold hypothesis. What if 3I Atlas was not a natural object, but an artificial structure? Avi Loeb coined the term Trojan horse to describe this possibility. The idea, inspired by the famous ancient military ruse, was that the ideal way to introduce a probe into an inhabited system without attracting attention would be to disguise it as something everyone considers harmless, a comet. If an advanced civilization wanted to study thousands of systems simultaneously without detection, it could send automated probes camouflaged as interstellar comets. These probes could travel millions of years, using stellar energy to adjust course with strategically oriented gas jets. Once in a system, they could collect data on planets, atmospheres, and perhaps life. 3I Atlas's anti-tail could be an oriented engine controllably braking it. Its ecliptic-aligned trajectory and encounters with Venus, Mars, and Jupiter could be part of a reconnaissance plan. The presence of nickel tetracarbonyl, a compound associated with industrial refining processes, could be a byproduct of its engine or a manufacturing residue. Its colossal mass could house internal compartments with instruments, power, or even small drones ready for deployment. It is not that I firmly believe this hypothesis, but I must admit it awakens an imagination that science rarely permits. Human-engineered interstellar probes do not resemble comets. But that is because our technological limitations force us to different designs. An advanced civilization might choose elongated shapes that cross interstellar dust with less resistance, coated with materials that withstand micrometeoroid impacts. Even its estimated age, potentially older than our solar system, could fit an artifact traveling from distant eras. However, we must be cautious. Proposing such an extraordinary hypothesis requires equally extraordinary evidence. And for now, we lack it. Science advances not through sensationalism, but through observation and comparison with models. Nevertheless, we cannot deny that 3I Atlas forces us to ask questions beyond our intellectual comfort zone. Personally, I find myself in a strange state. The idea that we might be facing technology from another intelligence fascinates me. But it also causes unease thinking about what it implies. That an object disguised as a comet crosses our system to observe us without detection produces existential vertigo. Therefore, even if the hypothesis proves false, it suggests how far we can go when nature surprises us. Faced with the temptation to embrace an artificial explanation, many scientists invoke Occam's razor. The simplest hypothesis is usually correct. From this perspective, 3I Atlas's anomalies could be explained as manifestations of rare natural processes. Some recalled that our sample of interstellar visitors is tiny. Just 3. We cannot statistically extrapolate the behaviors of billions of bodies from so few examples. Others pointed out that protoplanetary disks of other stars may have radically different chemical compositions. If a nickel and carbon-rich protoplanet was disrupted and ejected into interstellar space, it could become a cometary nucleus that releases nickel tetracarbonyl when solar radiation heats its surface. Sun-oriented jets could result from cavities or fractures exposing carbon dioxide deposits in one hemisphere while the other remains inactive. Ecliptic alignment could be a statistical coincidence that will seem less surprising when we detect hundreds more interstellar objects. In this line, astrophysicist Suzanne Fegner proposed another interesting idea. These visitors could act as planetary seeds. Her research suggests that when a young system captures a tens of kilometers object from interstellar space, that object can serve as a nucleus around which dust and gas accumulate, accelerating planet formation. If true, 3I Atlas would be a natural artifact, not artificial, but an artifact with a cosmic purpose. It would have wandered billions of years until gravity brought it to our system, where it causes no harm, but where it shows how worlds might have formed in ancient times. It was also suggested that the absence of iron in the gas surrounding the comet may be because iron oxidizes and remains trapped on the surface, while nickel combines with carbon monoxide to form tetracarbonyl, which volatilizes. Observed speed variations might not be active accelerations, but the result of uneven mass loss on the surface. When a jet emerges from a point, it creates thrust. If the comet is sufficiently massive, that thrust is very small. And the apparent ecliptic alignment could result from how galactic gravitational fields guide remnants ejected from more distant systems. For some, these natural explanations are satisfactory and demonstrate that the universe is more creative than any science fiction writer. For me, they have the virtue of reminding us that we must exhaust known possibilities before inventing new ones. The way information was managed also fueled curiosity. In early October 2025, the United States government entered an administrative shutdown implying temporary suspension of certain non-essential functions. Coincidentally, this period overlapped with 3I Atlas's passage near Mars, a key moment for observing its behavior from different angles. Many public and amateur observatories eagerly awaited data transmissions from spacecraft like Mars Express and Trace Gas Orbiter. However, the National Aeronautics and Space Administration ceased updating its tracking channels, and some servers displayed error messages. The official explanation was that, due to the shutdown, personnel responsible for updating websites were unavailable. This explanation, though plausible, fell on skeptical ears. How was it possible that, in the information age, such a large agency lacked an automated system for uploading data? Why did the page remain blank precisely when the comet passed behind the red planet? At the same time, rumors of unexplained radio signals spread on social media. Some claimed the National Aeronautics and Space Administration had captured a transmission from the comet's direction, and that was why an information blackout was imposed. Others spoke of anomalous flashes in satellite images. My reaction as a scientist was measured. I knew government shutdowns do affect logistics, and that sometimes staff shortages can delay data publication. But I also felt frustration because, in the absence of official information, baseless theories grow like mushrooms. Only weeks later did updates resume, and new comet data were published. It was learned that the anti-tail had transformed into a conventional tail, that the sun-oriented jet was likely caused by a localized carbon dioxide deposit, that the comet had been hit by a coronal mass ejection and yet did not fragment as expected. We also learned that the European Space Agency was preparing a series of observations with the Jupiter Icy Moons Explorer mission, which would pass relatively close to the comet in November 2025, as well as with the Juno orbiter in March 2026. These missions could provide high-resolution images and thermal data to determine if the nucleus has cavities or internal structures. For its part, the International Asteroid Warning Network announced a global campaign to refine tracking methods and better understand how to locate and characterize interstellar objects. I myself participated in a seminar where nickel spectra calibration was discussed, as well as distinguishing natural signals from possible technosignatures. In summary, although the National Aeronautics and Space Administration's silence generated suspicions, the scientific community continued working, sharing data and preparing to capitalize on the most important observation window of our lives. It was a lesson in how lack of communication can distort public perception of science. As the months progressed and we approached the late October perihelion, my reflection deepened. Regardless of whether 3I Atlas proves to be a comet with exotic composition, a camouflaged probe, or a planetary seed, its appearance has already changed our view of the cosmos. It highlighted that interstellar space is not empty, but harbors gigantic objects that can unexpectedly enter our neighborhood. It showed that planet formation processes can vary, and that the chemistry of other star systems can surprise us. It revealed that government agencies do not always communicate as we wish, generating distrust. And above all, it showed that the boundary between science and speculation is blurrier than we think. In every conversation I had with colleagues, the same question arises. What will we do if one day we discover an object that leaves no doubt about its artificial origin? This question is not new, but 3I Atlas placed it at the center of debate. Some fear that day will bring panic and chaos. Others dream of an encounter that will make us an intergalactic civilization. Personally, I believe the most important thing is to be prepared, not only technologically, but emotionally and ethically. Do we have communication protocols? Are we ready to accept that we are not the only intelligence? Can we handle uncertainty without falling into extremism? When I see the National Aeronautics and Space Administration activating planetary defense protocols while remaining silent, I see an institution trying to balance security with caution. When I read Avi Loeb comparing the comet to a Trojan horse, I see a scientist reminding us that scientific curiosity should not be censored by mockery. And when I read colleagues like David Jewett reminding us that most comets have their own personality and that we should not rush conclusions, I see the voice of experience. My hope is that, in the end, this story will help us find balance between openness and skepticism. Science needs both to advance. And for society as a whole, perhaps the lesson is that the universe is far vaster and more complex than our simplifying narratives. That the unknown does not always imply conspiracy, but that we should not close our eyes to the improbable either. Therefore, I invite you to remain attentive to these wonders. If this narrative has intrigued you, if you feel the search for truth deserves sharing, I invite you to share it, give it a like, and subscribe to our channel so we can continue exploring the limits of our knowledge together. Because in the end, our curiosity is the engine that drives us to look beyond our home and understand the place we occupy in the vast ocean of the cosmos.